Hey everyone, my name is Julian Testu. I'm part of the OCI Data and AI Product Management team. And today I'm pleased to be joined by my colleague as well, Carter Shanklin. Carter.
Hi everybody, I'm Carter Shanklin. I'm also in the Data and AI group. I'm responsible for our big data services.
Thanks, Carter. And today we'll be talking about integrating and preparing data for data science. So let's start with a quick safe harbor statement as we may go into some roadmap items. We'll make sure to mention that to you guys. And what we've been hard at work doing over the last couple of years at Oracle is building a modern data and AI platform on top of our Oracle cloud infrastructure that you might be aware of, such as networking, compute, storage. Now on top of these, you can find some of our platform services around integration, for example, Oracle Cloud Infrastructure or OCI data integration that I'll be talking about and that I'm the lead PM for. You're going to find data management services like the autonomous database, object storage for your data lakes, as well as OCI data flow that Carter will be covering in his part of the presentation. Above all of those services, we have our data governance layer handled by a product called OCI Data Catalog, which will be able to harvest metadata and help you see, what's part of your ecosystem. And then from a visualization standpoint, depending on your use case, we have tools and services around analytics, such as the Oracle Analytics Cloud, to take a look at the data in your data marts and data warehouses and build reports. And specifically for today's topic, tools and services like OCI Data Science that can help you build, train, and manage your AI/ML models. All of it in the OCI ecosystem in the Oracle Cloud Infrastructure. So let's talk about OCI data integration first, and I'm going to talk about how it can help you ingest and prepare the data, and then as I said after a demo and some slides, then Carter will pick it up and talk about how OCI data flow can help for that same topic. So let's start with OCI data integration. OCI data integration is our cloud-native serverless ETL service. So ETL stands for extract, transform, and load. And some of its key capabilities are the fact that it's fully managed by Oracle. It's entirely serverless. It's powered by a Spark platform that we manage, we administer, and we scale for you guys. It is offering a low-code, no-code approach to data integration. So we'll take a look at that in the next slide. It merges and I would say brings the best of the ETL offerings and the data preparation offering in the same solution. So we'll see how data integration helps you on the ETL and the data preparation side. And how you can prepare the data in a very interactive manner. Data integration also helps you protect your investments and your data integration processes as the schema evolves over time, which is very frequent with big data systems. So if your source and or your target shapes are changing, the data integration service is able to handle the schema drift and ensure that your processes will continue to run over time. So this is again powered by the Spark ecosystem, but we also have what we call ELT or push down capabilities, which means that some of the processing can actually be handled by the source and or the target endpoints that you might be leveraging. So it's a brand new ecosystem. It's available, a brand new solution. It's available in all OCI regions worldwide, and we've been launching it, sometime in 2020. So some of the key use cases for data integration are, number one, data integration for data science and, I would say big data and data lakes. So there, data scientists, data engineers will be using data integration to prepare and ingest the data, move it into object storage in OCI, which is our data lake layer, and then typically using services like OCI data flow to do large-scale data processing and looking at the data, visualizing the data, and building and training the AI/ML models using OCI data science. So that's our number one use case. It's also worth knowing that data integration can be used for your analytics use cases. And there, data integration will be typically used by ETL developers or data engineers that want to prepare and load data to ingest it into their data marts, their data warehouses. So typically the autonomous databases running on OCI, and then the reporting would be done using the Oracle Analytics Cloud, for example. So you can see how it complements, the rest of the ecosystem and the different things you can do with OCI data integration. So now let's drill down into some of the specific capabilities of data integration. And what I'm going to highlight with this slide is really the fact that we spent a lot of time trying to make sure that the user experience was as best as possible. So this is providing you with a low-code, no-code approach to data integration. So it's very visual. And what you're building in data integration are really visual programs where you express the type of transformations that you want to do in what we call data integration flows. And then in the end, when you run it, we generate code, and that's what runs on Spark or runs using an ELT approach or a SQL pushdown approach. So what you're looking at on the slide is an actual screenshot of the product. I'm going to give you a live demo in like 2 slides, and so you'll be able to get a feel, for how everything works together. So you have a graphical editor to build your data integration flows. At any point in time, you can preview the data. So that's where we bring in some of the data preparation concepts within more traditional ETL way of doing things. So I can click on a join and I can preview the data, and I'm going to see a live output of the result of that join. I can click on a filter and I can see the live output of that filter operator. And along the way, as I'm looking at the data, I can apply more transformations, such as like obfuscating the data, formatting dates, and I can do that using both the data preparation user experience as well as the ETL user experience. So it's really bringing you the best of both worlds in a single package, and again, in a very usable manner. So we've done a lot of work to make sure that you, as developers and data engineers, you can do more faster, and you can spend more time, like designing new things, bringing more value to your company and to your business versus maintaining existing stuff. It's very flexible. We have concepts of parameters in data integration where you can, take a job and parameterize it so you can run it pretty much as is in your dev environment, in your test environment, in your production environment. You have a lot of flexibility. You can parameterize like filter expressions, join expressions, and so on. So I'll show you a little bit of that as we get to the demo. So really, bottom line, in terms of benefits for you guys, being able to do more, being able to spend more time designing things with a simpler way of designing ETL processes, and while still having access to very powerful and flexible data transformations. So as I was telling you in the previous slide, you have the ability in data integration to visually preview and prepare your data. So what you're looking at, on the slide here is a screenshot of what we call the Data Explorer. In the Data Explorer, you're looking at a table view of your data. The data can be in the database, can be in a file, and as I'm looking at it, I can see profiling statistics. So I can see value distribution, min, max, and I can apply data preparation transformations on top of that, like changing the case, merging columns, applying a date format, and so on. So as I'm looking at the data, I can interactively and iteratively, prepare it, transform it, and that impacts the overall data integration flow that you're building in data integration. So you have access to, pre-built transformations that I'll be, talking about as we get to the demonstration. So now that we've talked a little bit about, what we have from an OCI ecosystem standpoint, some of the key functionality in data integration, it's time to actually take a look at the product in action. So now we're actually looking at a data integration environment. So I'm in a data integration workspace. I'm on a different screen, so that's why I'm looking slightly to the left, but I'm gonna definitely talk to you guys as I go through the example. We have an example of a data integration flow here. This data integration flow, what it does is it takes data from a customer's table, which is sitting in an Oracle database on OCI, on the Oracle Cloud Infrastructure. This is storing customers' information. I have revenue data, which is stored in JSON file, which is an object storage. And then my goal here is to prepare, transform the data, and then move it into an orders table, which is sitting in the autonomous data warehouse. And I'm going to use that as an example to show you how you can use data integration for your ETL and data preparation needs. In my data flow, I have access to a palette on the left. And this palette, shows you some of the pre-built transformations that we ship as ETL operators. So I can perform joins, I can perform filters, I can add expressions, I can perform aggregates with a group by, distinct, sort, and we can also perform union. Of course, there will be more operators coming up. We have monthly releases, so you can expect more and more transformations to come up as we keep on investing in the product. Now, how do you design such a flow? It's extremely simple. I can just go ahead and, for example, drag and drop a join. We've taken the customer's data, we're filtering it, we're taking the revenue data, we filter it, we aggregate it. Now it's time to actually join both of those data sets together, if you will. I add a join. I can enter, the join condition. I can specify the join type, all of it graphically in the UI. And then to finish the configuration of the flow of data, I can just, link join to my target, and I'm done with, I would say, the typical ETL way of building data transformations. Now, what I was telling you guys in the deck is that we've basically merged together both the concepts of ETL as well as the data preparation concept. So at any point in time in that diagram, in that data flow, I can actually preview the data. So I click on the filter. The filter expression is filtering customers based on their country code. So here I'm interested in the US customers. So I've added that filter. I can click on data. And this shows me a live preview of my data here for that particular filter. So we can take a look at about 2,000 records. This is a sample that we load at runtime. And then we can see here that it seems to be doing the right thing. As I'm looking at the country field, I only see United States. And to make sure that I had the right data on the source, I can, for example, go back to my customer source and I can click on data there and, filter to see the country fields. And I can see in my original data, in my source data, I did have data coming from Argentina, customers coming from Argentina, customers coming from Japan, the United Kingdom. So as I go back to my filter, I am now confident that the filter is doing the right thing. My source data looks right, so I can move forward. I can use the data view, the data preparation user experience to validate my data. Now, I can also use it to actually troubleshoot and uncover defects in my data. So, for example, here I'm seeing this city-state attribute in my data. It doesn't look right. It's mixing up the city and the state together. And I would like to do something about it. So we're going to actually, click on it and take a deeper look at it. So we can see on the right-hand side that the profiling panel loaded up. So now as I'm looking at city state, I can see things like value distribution with the bubble chart. I can take a look at some of the minimum, maximum values. I can take a look at a lot of different things. And I can use that data to then, that metadata, I should say, data about the data, to actually start building new transformations. So here, what I want to do, as I was telling you guys, is I actually want to extract the state information from that field and create a new state field. So what I'm going to do here is, I could use an expression and enter an expression, using functions that we ship with the product and come up with an extract expression, I would say. But I want to use the pre-built data preparation transformation. So I have an extract. You can see I have things like null fill-ups to replace nulls. I can change case. I can do a lot of different things. But here I'm going to pick extract. I'm going to enter a regular expression. And then that new field, I'm going to call it state. And then when I click on apply, this automatically adds up, as you guys can see over here in the middle, a new expression node. And you can see the syntax that data integration added to my data flow to extract the state information. So now I have a new state field that will contain that information. So that's how you can prepare the data by looking at it. Now, last thing I want to show you in the demo is actually how you then tell data integration where this data is supposed to go. So we know, we're loading the data into this orders table, but how do I know which fields is being targeted? So I do this by going to the map tab on the target. And here you can see both on the left and on the right side the fields that are coming in from your sources on the left and from your target on the right. And soon we'll be able to support multiple targets as well. Here Out of the box, data integration performs field mappings using a rule, which is automap by name. So if the names are matching on both sides, then it's gonna, basically load the data in each field. I can, take a look using the filters at what has been mapped, what hasn't been mapped. So here, let's say, I've seen that 33 fields are mapped, but 9 are not mapped. So let's take a look at them. Clicking on attributes not mapped. I can see that I have, state fields that are missing data. So why don't I look for, that new state field on the left-hand side, that we created together with that extract transformation, and I'm going to map it to state province just to show you how we do manual mapping. So and now state province is gone from the list of attributes that are not mapped because it is mapped now. It will get data. Now that's all great, but what if in the future, the field is not called state anymore? It's called, ST. What if, the shape changes over time? That's where, we have rules that we can set, and one of them is map by pattern. So when I go to map by pattern, instead of saying, field A goes into field A, I'm going to create a rule that says, things like anything that ends with name is going to go into target fields that end with name out. And this is going to be a pattern rule, which then is going to adapt to the evolution of the schemas on both the source side and on the target side. I can preview what the outcome of that rule is going to be. And then when I click on map, this is going to be a rule that's going to be evaluated at runtime, and then will ensure that your processes over time stay robust, resilient, and that your data will keep on being loaded into your data lakes, for example, as you work on your data science use cases. So now that we've seen a quick demo, let's go back to the slides and let's wrap up on data integration. So now that we've taken a look at data integration in action, let's take a look at some of the additional functionality in OCI data integration. So first of all, connectivity. OCI data integration can connect to a wide array of data sources and targets, including obviously object storage in OCI, the autonomous databases, and files, Oracle databases running on-prem, SQL Server, Microsoft SQL Server, Postgres, MySQL on the source side and on the target side, can connect both through public or private connectivity. So you have best-in-class connectivity to a variety of adapters. From a data processing standpoint, it runs, as I said, on top of a Spark infrastructure that we manage, we own, we administer for you guys. It can also run some of the processing on the database endpoints, source and targets. And as we'll see, it can also run on top of OCI data flow that Carter will be talking about. Actually, that's this slide here. If you want to control the actual environment that is going to run your data integration processes, the new functionality that we now offer is the ability to take those data integration tasks that you've defined visually and now, send them, run them using what Carter is going to talk about, our market-leading, Spark as a service offering, where you can select like the shape of your executors, Spark executors. You can select the amount of memory and so on. So, you can leverage our low-code, no-code approach and still, control what is going to be the runtime environment for data integration. So I hope you got a good idea of what OCI data integration is and how it can help with your data science projects. And now I'm going to hand it off to Carter to talk about OCI data flow.
Thanks, Julian. That was great. And so as Julian was talking about, next, I'm going to show you a little bit about OCI data flow. And data flow is really meant to be a fully managed Spark execution environment. So as Julian was talking about, and we've really seen at Oracle that Spark has become the dominant force really for big data processing, big data management. And Julian is talking, the data integration service does a great job of wrapping that up and giving that to you in a low code, no code type of form factor. But in some use cases, you need to get your hands dirty, you need to write the code, and there may be sophisticated processing that you need to do or existing applications. So that's really where data flow comes in. It's a fully managed Apache Spark runtime that really takes care of all the nitty-gritty details for you. The problem that most people run into with big data processing is with existing legacy technologies, you have to manage the entire stack from the top to the bottom, hardware, software, operating system. And so what you see is in legacy environments, people will spend 80+% of their time just keeping the lights on instead of doing innovation. What people really need is fully managed big data. So you can just worry about your code. You're just writing your code. You're not thinking about all those nitty-gritty details. Instead, you're letting the service take care of that. And that's really where data flow comes in. Okay, so the point of data flow is really because we have this fully managed environment, you're just worrying about your code, and that's going to allow you to build your applications faster, deliver your applications faster. And the point is basically imagine a world where instead of upgrading software or managing your own operations, everything is handled by the service. So all you really need to think about is that code. And in fact, that's what we'll talk about as we kind of go through and demo this. Let's talk about some of the key use cases for data flow. There are a lot of things that you can do with Spark. So this is by no means a comprehensive list. There's a lot of things that people do with Spark. Really, any Spark application that you're running today, you can take that, move that into the data flow environment, because it really is just a managed runtime for Spark. So if you've got those applications, if they don't fit into these categories, that's not intended to say that it won't work. But a lot of the key things that we see are people will, they'll offload their processing outside of the warehouse or outside of the database, offload it into Spark. We call that EDW optimization. Or maybe they'll take historical data, they'll copy that into the data lake, and they'll query it from the data lake. We call that active archive. Now, this event is really centered around machine learning and how to feed that machine learning pipeline and lifecycle. So really, we're going to zoom in on the data engineering use case. The Spark is very commonly used for data engineering because two reasons. Number one, Spark deals really well with messy data, unstructured data, semi-structured data, data with fields that are missing, data with corruption in it. When you're feeding that machine learning pipeline, one of the hidden costs of machine learning, a lot of times people will focus on, what are the machine learning algorithms? But the real cost is preparing the data, cleansing the data. And that's where tools like Spark can really help out. So we're going to zoom in on that data engineering, cleaning our data, preparing it so that it fits neatly into that machine learning pipeline. So let me actually, let's get into this. I'm going to kind of do the demo as we go along here. So what we're going to do right now, we're actually going to take a look. We talked about how data integration service is a low code, no code experience. Data flow is really meant for the developer, the Spark developer. And Spark development, you can do that in a variety of languages, Python, Java, Scala. And data flow can take any of those and run with them. So I'm going to, this example, I'm going to basically show a Python-based Spark, PySpark data flow application. And what we're going to do with it is we're going to take some messy data. I've got some data and I want to feed it into a machine learning pipeline, but the data is a mess and I can't effectively feed it into that pipeline until I clean it up a little bit. So that's the objective here. Let's take a look at that data here. So this data, it's a data set that I downloaded from a public source, from an ML repository archive. This data set, if you look at it, it talks about cars, automobiles. It gives some data on who the manufacturer is, what year it was produced, how heavy it is, so forth like that. But if you look at the data closely, what you'll find is some of the fields are missing. And this is a very, very common problem. For example, if I go down here or scroll down a little bit, what I can see is this field here is missing the horsepower column. So this field here for the Ford Pinto, if you were old enough to remember the Ford Pinto, the vaunted, this missing the field for the horsepower. So machine learning algorithm, and this is very relevant if you want to do something like predict miles per gallon or predict fuel economy. This is a field you kind of want to know about. So, and this is a very, very common thing with machine learning data sets. Some of the data is missing, some of the data is in a bad format. And if you take that dirty data and you throw it into your machine learning algorithm, it's all garbage in, garbage out. So you got to make sure stuff like this gets caught at the source, fixed at the source before it goes and ruins anything else. So very, very common problem. So what can we do about this? So, Spark is very commonly used to fix up, clean up data sets. One strategy, and there are many strategies for dealing with missing data, but one strategy would be to look at data points that are adjacent to that data point, and then say, take an average or take something that is related in that group. So what we could do here, instead of just throwing this data point out completely, what we could do is actually say, we could probably get a good estimate of that horsepower if we average based on this manufacturer and the size of the engine. We could probably make a pretty good guess of how many horsepower that thing is going to have. And Spark makes it very easy to do that. So this is not necessarily a run-of-the-mill kind of ETL drag and drop kind of thing, but a very, very common thing you're going to do when you're cleaning your data up for machine learning. So I won't go into all the deep dive details, except to say that this is just plain vanilla, ordinary Spark code. And the really nice thing about Dataflow is I can develop Spark code locally in my environment. When I'm satisfied that it works the way I want it to, I can just take that code and move it to the cloud and then run it at any scale. So very, very powerful. So this code is just plain vanilla, ordinary Spark. It loads that data set. It does some massaging of that data. So I won't go too deep into what it is actually doing, except to say that it's basically saying, we can get a good guesstimate of that horsepower. If we look at that manufacturer, we look at other associated fields, we can get a good guesstimate and not have to throw that data set away. So what I can do here is, in my environment, as I manage my Zoom windows here, I can run this code locally. And when I run this code locally, the way I've got this set up is, when I run this PySpark code locally, it's going to read the data from the cloud where it lives. Let me show that in here. So my data itself is sitting in this cloud location. Okay, so I have the CSV file sitting in the cloud, and I'm going to read that directly from the cloud. And where I'm going to write the output of this depends on whether I'm running in the cloud or not. So the way this code is set up, if I'm running in the cloud, I'm going to write it back to the cloud. Otherwise, I'm going to write it locally. So the process is done, and we see there's some new files here. Let's take a look at that and see what's happened. So if we look at this row 34, had the missing value before. If we look at it now, basically what we've done is we've taken that record, and we've kind of guesstimated what the horsepower is going to be. So now we have a value that we can feed into machine learning. The data is cleaned up, and that's all great. So now, okay, that's cool. We got Spark code, it runs locally. That's all nice, but we really want to run this in the cloud. Like, I don't want to run this on my laptop with a large data set or try to run it every night. What we can do at that point is take this Python, the PySpark code, we can upload that to the cloud and create Dataflow applications around that. So let me talk about how that works. So if we switch back here to my browser, okay, so what I've done, in addition to preloading the data, I've also preloaded this application, the PySpark application. So it's sitting there within the OCI object storage system. And what I do within Dataflow at that point is I create a Dataflow application. Dataflow application is effectively templatizing that PySpark application. So this data flow application, it points to the PySpark code within object storage. And now that I have this, I'm able to run this PySpark application with any scale that I want, any amount of resources that I want. I can just run that here with a very simple interface. So I'm just going to say, I can choose how much memory, how many CPUs I want to use there, and just hit run on that. As we run that PySpark application, what happens is there's a net new cluster that's just spun up on the fly, just materialized on the fly out of nowhere. So this is totally serverless. It's only when I actually run the application that any resources are allocated. So I'm really only paying for the resources I use while I use them. So I hit run on that, and what we see is there's a new run here. The resources are being allocated for that. I can drill into that. In fact, I think I took so long to get to this that the run is already completed. So what we can see there is the run is either executing or it might actually be completed. We're not quite sure which. In fact, it's just getting started here. So as the cluster is just materialized on the fly, I can go in, I can see the operational UIs. And in fact, as it goes through, we'll see that the data is going to be written out to the cloud, just like it was written out locally previously. Okay. Now let's talk a little bit about, I'm going to switch back to slides briefly, if I can find the right window. Okay, so that's one of the key benefits really of Dataflow. You can develop locally using your tool of choice, run it in the cloud, run it at any scale. Some other benefits that you see with Dataflow, because it's a totally serverless model, we actually consolidate all of the information about all of the Spark applications into one place. Let me show you what I mean. So we go back to the browser here, and we'll close that. What we see is within this panel, we have all of the information about every Spark application that has been run in the history of this account. You can see what the type of application was, when it was run. You can see how much data it processed. You can filter down by the person who ran it, whether it succeeded or failed. Very, very powerful, because you get the single pane of glass of all of the applications that have ever been run. Not only that, you can drill in to an application, even an application that was run months ago, years ago. You can drill into that, and you can view the operational UIs associated with that historical run. So let's say that you had a run fail last night. Very, very common scenario. Run failed, you're not quite sure why. We have all of the history there. You can go in, you can debug, you can diagnose, get the logs, figure out what happened if you need to do any of that kind of investigation. So we really take all of the operational burden out of your hand when it comes to running Spark applications. You don't have things to install, upgrade. We're really handling all of those common operational issues that you would otherwise run into. Okay, let's kind of tie things off a little bit back to the slide where we talked about, we consolidate that information, but we also simplify the troubleshooting. You saw that we maintain the Spark UI even for runs from months ago. You can get the logs. You can get the application output. Every time you run an application, we capture the output. We store that for you as well. Very, very simple operations. With running Spark jobs with Dataflow, you don't need dedicated operations staff. One last point on this, enterprise-grade security. We spent a lot of time on security in Dataflow. There's role-based access controls for all of the items like runs and the logs and the operational UIs, all controlled by role-based access controls in the OCI IAM system. When you run a Spark job with Dataflow, we set up the security to really maximize convenience to the access of the OCI resources. So when your Spark job is running in Dataflow, the Spark job impersonates the person who launches it. So that means when I launch a job in Dataflow, that Spark job is able to read any data that I could read or write any data that I could write. And the same is true regardless of who launches the application. So one of the interesting things you may think about when we looked at our application, there were no passwords, there were no tokens, there were no keys. All of that was injected at runtime. And that's what allowed me to read that data and write the data back. In addition, you can run in a private network. So if you've got on-premises resources, or if you've got data, or if you've got systems that need to be air-gapped from the internet, those kinds of scenarios are also possible.
Yeah, thanks, Carter. So I'm seeing a question for you, Carter. Can Spark train machine learning models as well as data preparation?
Yeah, absolutely. Great question. Spark is popular for a variety of tasks. We talked about the data prep. We talked about data cleaning as a precursor to machine learning, but you can also do machine learning within Spark itself, even from the same job. So you could clean the data first and then build a model on top of that. Spark is good for machine learning tasks where you have a very large amount of data, and so you need to spread it out across a bunch of different things. So absolutely possible. The question for you, Julian, actually next is, is it possible to orchestrate data integration tasks, or can you schedule them? Like if you want to run it every midnight or something?
Yep. Great question, Carter. Yeah. So we have right now in beta both I would say workflow functionality, so orchestration functionality with what we call pipelines, and then we also have scheduling functionality in beta at the moment. So it's going to be generally available, sometime this year in 2021. So the answer is yes today. So you can take, a data integration task, you can take a data loader task, you can, define a sequence of execution, then you can schedule it, hourly, weekly, monthly. And then soon, in addition to that, we'll be able to schedule and orchestrate data flow as well in the context of data integration, data science tasks as well. So, for your orchestration needs, you definitely can go to data integration to cover this. Yeah. Thanks, Carter.
Sure.
So back to you, Carter. Another question that I see from the audience here, can OCI data flow connect to Oracle databases?
Oh yeah, So data flow is the best way to think about data flow. This is a way to run Spark jobs. So really anything that Spark can talk to, you can talk to it in data flow. Spark can talk to Oracle database. It can talk to other third-party databases, a lot of different sources. So really anything that Spark can talk to, data flow can talk to.
Okay. Sounds good. Yeah.
Another one coming in for you, Julian. Can DIS talk to SaaS applications, ERP cloud, other SaaS applications that people may be using?
Yeah, that's a common request. So that's part of the roadmap at the moment. That's why we have the safe harbor statement at the very beginning. So very soon, yes, you'll be able to connect to ERP cloud. Actually, that's the first one on the list. And then soon after, we'll be adding more and more. But we do definitely see the need to get data from SaaS applications, Oracle apps as well as non-Oracle apps for data science use cases or analytics use cases. So this is coming up. Yeah, definitely very high, on our list.